Welcome to online classes. I'm Shilpa, lecturer in computer engineering, working with Dr. B.R. Ambedkar Government Polytechnic, Karimnagar. In previous lecture, we discussed how we can open multiple files with single object and how we can open multiple files simultaneously, that is using multiple objects for creating file stream classes. Theoretically, we are discussed about these concepts. In today's lecture, we are going to discuss what is meant by file opening mode. Okay, what it means actually. So, and what are the functions of seek and tell? What is the use of seek and tell functions? Of course, we are having seek G, seek P, and tell G, tell P functions. So, what is the purpose of these? What they do when we use these functions in our program? We will discuss in today's lecture, and also we will examine some example programs on opening multiple files with single object and multiple object, because in previous lecture we discussed only theoretically. Today we will execute the programs on these two concepts also. So first, what is mean by file open modes? So what is actually mean by mode? Mode means when we are trying to open a file, of course, we open a file to perform a particular operation. Okay, that is if we want to read the content of the file, we open that particular file for that purpose only. We can read only, and if we want to write uh, to the file, then we normally open the file and we will write the file. That is here when we are trying to open a file, how it to be opened. How it to be opened, that is for reading purpose, that is to read the content of the file, or to write to the file. Okay, so how it to be opened, how the it to be opened, that is specified by the mode. Normally when we open a file based on our particular our purpose, okay, that is in order to read the content of the file, or in order to send content to the file, we open the file. And of course, if we want to append the file, append to the file, okay, that is also another mode. That is we want to open that particular file for a particular purpose. That may be any of read, write, or append. Okay, that is known as mode. How the file should be opened for read, for write, or for append. Okay, that is actually mean by open. For which, for to perform which operations we are going to open this particular file, that is denoted by the word mode here. So general form of the function open with the two arguments is, that is when we discussed previously, using object. If you want to open the file, normally stream object dot open, and there we specified only the file name without specifying the mode. So that is with single argument. But here our open function may have two arguments. Okay, this is the syntax for opening or calling the member function open with two arguments. One argument should be the name of the file, and the second argument should be the mode, that is for how we are opening that particular file, for what purpose we are opening that particular file. Okay, and the second argument specifies the purpose for which the file is open. Here always the mode specifies the purpose for which we are opening the file. Okay. And the prototype of these class member functions contain default values for the second argument. That is, if you are not passed the second argument, then the second argument is having some default values. So in previous lecture we discussed only sending file name as argument to the function open. You are not passed any mode value. So if in the absence of this particular mode, the computer may take some specific some default values. The absence of this variable, the compiler will take some default values. what they, and the default values in the absence of actual values are as follows. Okay, iOS in for iStream function. Okay, that is whenever we created object for ifstream, that is input file stream class. Okay, then this will be the default value for the mode, that is iOS scope resolution in. iOS scope resolution in. What it means? What it means? So meaning open the file for reading only. Open the file for reading only. And the default value is iOS scope resolution operator out for OFStream function. Okay, that is when we create an object for OFStream class, then the default value for the second argument of member function open is iOS out. What it means? Open for writing only. That is here whenever by using the output stream object, if you pass some file, then it indicates that the file should be open for writing only. The file should be open for writing only. These are the default values which are assigned based on the object which we created for this specific class, that is ifstream or OFStream. Okay, these two are the default values for the second argument of open function, or as a value of mode in the absence of this mode. Clear? When we create object for ifstream, then the default value of mode is in, because we created in file, input file, stream. Okay, so that means the file should be for reading only. Likewise, if we create OFStream class object, then the default value will be iOS out. Okay, and it indicates that the file is open for writing only. Now, the file mode parameter can take one of constants defined in the class iOS. So, as we discussed here, by default, the value of this mode may be of iOS scope resolution in or iOS out. Like that, the file mode parameter can take one of constants defined in the class iOS. Of course, one or more constants. Okay, that means we can open a single file in more than one mode. We can open a single file in more than one mode. And the possible mode parameters are here. The possible mode parameters are the possible values for the mode parameter are first one iOS in, that means it indicates that the file is going to open in read mode, and iOS out, that is here we are opening the file to write only, and iOS append app, and all the data you write is put at the end of the file. Okay, and it calls iOS out. iOS out. So here if you observe, there is a clear difference between out and app, append. So whenever we create a file in this particular mode, if the file exists and the file having some content, then the compiler simply deletes all the content of the file and it opens freshly. But whereas if we use this particular mode app, then it opens the file which is already exists, that means which is having some content, and it is used to write the new data at the end of the file. Okay, and it calls iOS out. And another mode is iOS ADE. So here also all the data which we write is put at the end of the file, that is also appended, but what it do, it does not call iOS out. Okay, it is not called, that is iOS out means write only. Okay, it will not call the file in write only mode. Okay, this is only here After that is in order to append, it opens the file write only mode. It is not open the file in write only mode. That is only the difference. And iOS scope resolution operator truncate, that is what it do, it simply deletes all previous content in the file. If you don't want the previous content of your file, then it simply deletes the previous content in the file by using this truncate. And no create. Okay, so whenever we are trying to open a file, if the file does not exist, okay, normally the operating system creates a file with that file name, but when you specify like this, that is if this is the mode iOS scope resolution no create, the file does not exist, opening it with the open function gets impossible because it is not allowing us to create no create. Okay, it is not allowing the operating system to create a new file. The file does not exist in the system. Normally, when we are trying to open a file in output stream, normally if the file does not exist, then it creates the file. Okay, but here if you specify this particular mode, iOS no create, it will not. If the file does not exist, it will not create the file. And no replace, that is if the file exists, trying to open it with the open function returns an error. Once a particular file is created and that is stored in the system, okay, this particular mode, that is iOS scope resolution no replace, simply returns an error if you are again trying to open the file. Okay, already that file is saved in the disk, and if you are want to again open the particular existing file, then if you use this mode, then it returns an error. It returns an error, no replace. Okay, not allow the programmer or the user to modify the or to change or to replace the content of a file or even the file. Not allow the programmer to replace the existing file. Okay, this is the purpose of this mode. And iOS scope resolution binary, that is here if you specify this mode, then it opens the file in binary mode. It opens the file in binary mode. Binary mode means which all the contents are represented in binary format, that is using zeros and ones. It opens the file in binary form, that is in zeros and ones. Normally when we save the file, though we have written some English like words using special symbols or digits or anything, whenever actually the file should be stored, the file is converted into its equivalent binary code. Its equivalent binary code, that is all the content is converted into zeros and ones, and it stored on the disk. Okay, so if you specify this particular mode, then the file is open in binary mode. Okay, these are the different file modes which we can use as parameter, that is second parameter for the member function open when we are trying to open a file. Okay, based on our purpose, we can use any of these file modes, and these two are the default values for the mode. Okay, based on the object you created for a particular fstream class. Okay, these two are the default values, depends upon the object which is created for a particular fstream class. Okay, and now file pointers. What is actually mean by file pointer here? So when we open a file, if you observe, always the cursor will be at first position. Yes or no? Okay, that means here already we are here opening already existing file. So what it thinks, so the file may be read by the user. Okay, that's why normally the file content starts from the first position in the file. So that's why here it always points the first character in the file. Okay, how it is possible? Okay, and if you are opening in append mode, okay, so normally we append or we write the data at the end of the file. At the end of the file, that means here the cursor should point to the last or end of the file. Okay, how it is possible? Okay, now file pointers that can be possible using file pointers. Each file has two associated pointers. Each and every file has two associated pointers known as the file pointers, and that is those two file pointers are input pointer and output pointer. Here use these two pointers to move through the files while reading or writing. So if you are reading, so we normally we need to start from the first position of the our first character in the file, and character by character we simply pass, and we will read all the contents or all the characters of the file. Okay, if you are writing, so starting from the end of the file, whenever we type something or we send data to the file from the program, so it is appended. That means here also the cursor will move from uh, some position to another position. Okay, that is advanced, it moves advanced. Okay. Here use these two pointers to move through the files while reading or writing. Okay, these two pointers are used to move through the files when we are performing reading or writing operations. An input pointer is used for reading the contents of a given file location. Input pointer is used for reading the contents of a given file location. So normally it points to the first character or first position in the or first location in the file. Okay, so it is used to read that particular content. Okay, after reading first character, the cursor will be moved to advance, that is to the next position. So from there we can read, and it moves to the next position, that is third position, and we can able to read the third character also. Like that it move on till the end of the file. Okay, and whereas this output pointer is used for writing to a given file location. So here output pointer is used for writing to a given file location. Okay. By default it points to the, or it will be at the end of the file. So using this output pointer we can able to write data from that particular location. Okay, these two are two different file pointers. Input pointer, so input pointer is used for reading the contents of a given file location, and that is the location to which this particular file points, and output pointer is used to write from the uh, pointer location which is pointed by the output file pointer. And each time an input and output operation takes place, the appropriate pointer is automatically advanced. Okay, whenever by using this either input or output pointers, if you perform any operations, then automatically here the pointer will be advanced, that is uh, moves to its next location or next position in the file. Automatically it moves to its next position. Now What will be the default actions? What will be the default actions? So when we open a file in read-only mode, the input pointer is automatically set at the beginning so that we can read the file from the start. So as we discussed, when we open a particular file in read-only mode, that is here we are going to read the content of a file. So obviously it always starts from the first position of the file to last element or last character of the file. Normally we read from first character of the file to last character of the file. Okay, that's why here the input pointer is automatically set at the beginning so that we can read the file from the start. Okay, we should not start from middle of the file because we need to read the entire content of the file, not from a particular position in this case. Okay, we are trying to read, we need to read entire content of the file. That's why when we open a file in read-only mode, here this input file pointer points to the beginning. Okay, and when we open a file in write-only mode, then the existing contents are deleted and the output pointer is set at the beginning. It also sets the output pointer at the beginning, but what it does is simply deletes the existing content of the file. Here we are trying to open the file for write-only mode. So when we specify this, simply what it do, it deletes all the contents of the file and it sets the output pointer at the beginning. That is from the first character it is ready to accept the data, because previously whatever the data or whatever the content in the particular file, that was deleted. If you open the file in write-only mode. Next, when we want to open an existing file to add more data. So, first case, we are opening a file for read-only mode. So, the input file pointer uh, sets the pointer at the beginning. And if you open a file in write-only mode, then the compiler, the operating system deletes its previous data and it sets the file pointer at the beginning. And when, if you want to open a file, that is here, if you want to append or write some more data to the file existing file, then here simply it opens the file which is already exist and the file pointer moves to the end of the file. Okay, so when we want to open an existing file to add more data, the file is open in append mode. This moves the output pointer to the end of the file. It is not deleting the content of the file. Simply it moves the output pointer to the end of the file, so that here whatever we write, that will be added from that particular end. Okay, previously that is end of the file, but now starting from that we are going to send or write to the file. So it points or it sets to the end of the file. So here you can observe, if we open a file for only read only, okay, if the file is having some content like hello world. Now when we open the file in read only, then here this is the input pointer. It simply sets to the beginning of the file. Okay, and if we are opening in append mode, that is for writing more data. So this is actually content of the file, and we are trying to open the file in append mode. Okay, so now the output pointer points to the end of the file. From here we can add or we can write data to the file. So here the output pointer points to this particular location. And if you open a file for writing only, okay, so it simply deletes the previous data, that is here, as we are having some hello world as the content of the file. It deletes the entire content of the file and the output pointer points to the first beginning or first location. It points to the first location. Okay, and here file pointers manipulation functions. So till now what we discussed, how we can open a file and how we can open a file in a specific mode, that is for read only, write only and append. Okay, so this is from in order to read from a starting position, and in order to append to a end of the file. And if you are opening a file for writing only, it simply deletes the entire data and it points to the first location. Now if I want to read the data from fifth position, I don't want the first. Okay, hello, that is 1 2 3 4 5 characters or 6 characters. I want to read from this one W and till end of the file. Okay, this is one case. Instead of reading now, or instead of getting the entire content of the file, I want to access from a specific position from the beginning. Okay, or I want to read some uh, characters with respect of end of the file from end to 4 characters. After beginning, 6th character. I want to read 6th character after the beginning. So this is the beginning pointer, and after 6 means 1, 2, 3, 4, 5, 6. So from W you can able to read. Okay, and here with respect of the end of the file or end pointer, previously 5 characters from starting from beginning and moving in backward direction if I want to read. Here from starting or beginning, I am going to read, or I am going to jump from this input point, that is this location, to a particular location in forward direction. That is with respect of or by specifying the beginning. And likewise by specifying the end, I want to access the data in backward direction. Okay, that may be one requirement. Or at a particular position, that is currently the cursor will be the possible the possible locations of a particular pointer can be point are beginning, ending, or in some cases current position. Some cases current position. So from beginning to after beginning 5th character I want to read R, that is in forward direction. Or with the respect of this end pointer, I want to read 5 characters in backward direction. Or third case, I want to read the content from the current location. So there may be some possibilities. Okay, so based on that, how we can access. To move a file pointer to any other desired position inside the file, here file string classes support few functions to manage the movements. So in order to move the file pointers, so that is for reading, the file pointer will be at the starting, and for writing, that is append, the file pointer at the points to the end of the file. Okay, so if I want to move this file pointer in between the content of the file or throughout the file, then we are having some functions, few functions to manage the movements. Okay, so here we are having seek G and seek P. G means get and P means put. Okay, so normally get using input, get means getting input, and P means putting output. Okay, based on that, here we are having seek G and seek P. Okay, seek function performs the same, but depends upon the G or P, the pointer will be changed. That's it. C always used to move. to a specific location. Seek is used to move a pointer to a specified location. Okay, seek. And if we specify seek G, then it moves get pointer or input pointer to a specified location. And if that is seek P, then it moves put pointer or output pointer to a specified location. Okay, these are only the things we need to remember. Seek G is, seek means moving a pointer to a particular location. If we specify seek G, then it moves only get pointer to a specified location. If that is seek P, it moves output pointer to a specified location. Okay, this is one function. Of course, we can say seek with two different that is modes of two different formats. Seek G and variations. Two different variations of seek G and seek P. Like that, we are having one more one more function that is tell G. Tell G. Here, always the tell function gives the current position of a pointer, of a file pointer. Tell always gives. Here seek moves. Simply it moves. That's it. Okay. But here tell. It tells us at which position a particular pointer is. Okay. So tell. It tells us. And of course based on the GRP. G is for get pointer and P is for put pointer. So tell G gives the current position of the get pointer or input pointer. It gives the current position of the input pointer, and tell P gives the current position of the put output pointer. Okay, these four are the functions which are used to move the file pointer in a file. Seek means simply it moves the specified pointer to a specified location, and tell it returns the particular location of a particular point, current position of a particular point. That depends upon either G or P. G means the input pointer and P means output pointer. Okay. So for example, IN file. Normally we create this in file for IF stream. Okay. So that's why input stream. That's why we are using G. Infile.cg 10. That means now here it simply moves to the 11th byte, because always the data starts from 0th location. So as the indexes of an array, always the indexes of an array starts from 0 to n minus 1. Okay, likewise here the content of the files also represented in the same way. So that's why here though we specified 10, it points to the 11th byte. It points to the 11th byte. It moves the file pointer to the byte number 10. Okay, byte number 10, that means 11th byte. Bytes in a file are numbered beginning from 0. That's why it points to the 11th byte. Okay, this is one example. Of course, we will see some example programs also based on this using this seek G, C, P, tell G and tell P. And now specifying the offset. How we can specify the offset? So here always the cursor may be at starting, and this is the end of the file. Okay, and here when I specify out file, this is the object created for output stream. That's why here I am using seek P. I am telling the compiler to move mth byte in a file. That is, I want to move the output pointer to the mth position, specified location, right? So that is mth location. Okay, then here it indicates that from starting to m bytes. From starting to m bytes, this is called as offset. Jumping from starting to a specified location, it is jumping. Okay, so this is called as offset. Okay, and action of single occupancy seek function here, this is, so this difference is called as offset, that is specified here as the argument for seek p function. And offset, here this is the syntax for that, seek g offset comma reference position, likewise seek p offset comma reference position. Okay, because here based on some or with respect of either starting position or current position or end position of a file pointer, we are moving the cursor. So we need to specify the offset from beginning or from end or from current position, how many bytes the cursor has to be moved. The cursor has to be moved, that should be specified here, that is offset. Specified here, that is offset. Okay, so these are the syntaxes for seek g and seek p, which is having two parameters, offset and reference position. So what is meant by offset? Offset represents number of bytes the file pointer is to be moved from the location specified by the parameter reposition. Reference position actually, reference position. Okay, that is here offset represents number of bytes the file pointer is to be moved. Okay, from the location specified by the parameter reference position. From this particular position, because here we are referencing, that is the reference position may be of any of these three values, that is IOS begin, IOS current, IOS end. Okay, only we may have three reference positions, that is beginning, end and current. Okay, with respect of these reference pointer, how many number of bytes the file pointer should be moved? The file pointer should be moved, that is represented with this offset. And of course reference position, that may be of these three values. One is IOS beginning, that is start of the file, that is the cursor is now points to the first position of the first character of the file, and IOS current position of the pointer, and IOS end of the file. It points to, or the file pointer points to end of the file. These are the possible values for reference position based on our with respect of this reference position. We need to specify the offset. Okay, so when we specify like that, with respect reference of this particular reference position, that here that many number of bytes has moved. Okay, that is called as offset. Now, so if you observe some examples here. Okay, so here pointer offset calls, how this pointer, that is seek, in case we have taken only G, that is input file pointer or input file, okay, file pointer. So if this is the object created for input stream class, that is f out, okay, or f in, whatever may be, if this is the f in, then that will be clear, because always G means input file, right? So fin dot seek G, all are seek G only, so we can modify all them as fin only, because that indicates that normal terminology. Okay, in general normally we use file input, we use in fin. If that is output, then we use f out. Okay, like that we can call this. Okay, fin If we want to use for output stream object, then you can use that. If this object may be of created for any object, we not at all specify this is FOUT is created for only output stream. That name can be given for even uh, that is input stream class, file input stream class also. But in normal terminology, we use fin for input stream. Input stream. That's why here also I am specifying the object fin also, fin only, not FO. Okay. If I am calling this SIG by specifying the values like 0, IOS beginning, that is this is the reference position and this is the offset. Okay, so with the reference beginning, always beginning points to the first character in the file. Okay, I am providing offset 0, that is it has to with respect of beginning, it should be uh, 0th byte it should represent, and the cursor should move from beginning to 0th position. So that is nothing but go to start. That is equivalent to go to start. That is, if we want to send the cursor to the starting position, then we can call this CG by specifying 0, IOS beginning. IOS beginning. And like that, if we want to move the cursor or we want to stay the cursor at its current position. Stay. We want to tell the pointer variable that you should stay at your current position only. Then here I need to call this CG function by specifying 0, IOS scope resolution current. IOS scope resolution current. So that is with reference this current position of the cursor 0th byte. That means here 0th means nothing, right? So it stays at the current position. And like end 0. So it go to the end of the file. And here these are the important. Actually here we are specifying the offsets in positive offsets and also negative offsets. Here 0. So they will be at the same position at the beginning, at the current, and at end. And if you are passing m, IOS scope resolution beginning. Okay. So with respect of the uh, beginning, okay, beginning position of the cursor, we want to move to mth byte or mth character in the file. Okay, what is the meaning of this one? This is reference position and this is the offset. So with this reference position, that is beginning, we want to move to mth position. Okay, so that means here what you do, what will be the action? Move to m plus 1th byte in the file. Because beginning it is having some 0 and m means m plus 1th position. And likewise CG m, IOS current means go forward by m bytes from the current position. This is with respect of beginning position. Okay, this is with respect of current position. From current position, if you want to mth byte, then we use m, IOS current. Okay, and likewise even we can use negative offset values. That is, if minus m, IOS current, always minus means in backward direction, positive forward direction, negative backward direction. So here what it do, it simply go backward by m bytes from the current position. It goes backward m bytes from this current position. Okay, likewise CG minus m, IOS n. That means from end go back to mth byte. Okay, go backward by m bytes from the end. Okay, even we can use for seek p. So that is even we can move the output file pointer. Okay, if we want to write it at a specific position, then we can move the output pointer, that is seek p, using this particular function seek p and specifying the offset and reference position. And like that, even we can have tell p and tell g. Okay, so here we are having some programs on how we can use this seek p and tell p, and tell p or tell g are not having any arguments, because simply they returns the current position of the or current right position of the file pointer. Okay, it returns the current position of the file pointer. So it is not having any other arguments. We will discuss that in next class. So in today's lecture, we discussed what are the different file modes. Okay, in, out, and append. Okay, and also normally we use these three, and also we are having some more file modes, that is binary is also there, and no create, no replace, truncate, and what is the purpose of file pointer and how these file pointers will be moved with respect of read or write operation. Okay, so what are the default actions or default operations took place by these file pointers. Okay, that is for here we discussed for read, write, and append. Okay, and also we discussed about some functions which are used to move the cursor in the file, and also in order to know the current position of either output stream pointer object or input stream object. We use tell p and tell g, and seek g and seek p are used to move the pointers to a specific position, and where this tell g and tell p gives the current position of the particular pointer.